Okay, target 5 again, law of signs ambiguous case still. Last time in the video we looked at what happens to give you no triangle, that there's no triangle that exists, and this time we're going to look at something else. So we're going to start with this example. We're going to go through the law of signs, setting up, and we're going to solve for angle B because we have both A's and we have side B. So 29 divided by sine of 58 degrees is equal to 15 over sine of B. We'll use the law of signs, solve that proportion, and we're going to get sine of B is equal to 15 times sine of 58 degrees divided by 29. So we'll type that in the calculator and find out what decimal that is. 15 sine 58 divided by 29. And I get 0.439. So we'll take the inverse sine of that. Second sine of, I'm going to type in ANS. That way you realize I want you to type in the actual answer and not the rounded answer. So inverse sine of the previous answer. Uses that stored value, I get 26.017. So we're going to round that to the nearest tenth as 26.0, or just 26. So B is going to equal 26 degrees. I can also find angle C by doing 180 minus the ones I know. So 180 minus the 58 degrees and minus the 26 degrees. So 58 and 26 minus 180, 180 minus 56 minus 28, and that's a 96-degree angle. I'm not going to keep going to solve for sine C. I really set up this example so that I could use it in a little bit. So I have a 96-degree angle and a 26-degree angle. I'm going to fill those in on this slide. 96-degree angle for C and 26-degree angle. Is that right? 96 and 26 goes with the 58 degrees. Okay, so we'll come back to this example. I want to point out that I had an acute angle A, and then I had opposite sides and another side. So same thing. In this one, I have an acute angle A, 74 degrees, and then the information. So I'm going to do the law of signs same way on this one. I'm going to say that the side A, 12.5, divided by sine of 74 degrees is equal to 12.8 over the sine of B. I'm going to solve that proportion and get sine of B is equal to 12.8 times sine of 74 degrees divided by 12.5. And then I'm going to use my calculator and just do the rest of that. So 12.8 sine 74 divided by 12.5 gives me 0.98. I'm going to take the inverse sine of that answer. And so B is equal to 79.8 degrees if we round to the nearest tenth. So 79.8 degrees. And then if I do 180 minus the two numbers that I have, so 180 minus the original 74 minus the 79.8, I can get the third angle C, 26.2. And again, I could find side C, but I'm not going to for the sake of time. So I've showed you two problems with the law of signs that all I did was show you kind of how to find that second angle. Here's where I want to show you that's different. I did call this the ambiguous case. There is something that is different that's going on. In the triangle you see right now with the 96, the 26, the 58, the given information was 29, 15, and a 58 degree. And that given information gave me this triangle, and it gave me exactly one triangle. And I'm going to show you how I know that in a minute. Now that seems weird because every problem we've done has always given you one triangle. But on this second problem, this given information that I have, the 74 degrees the 12.5 and the 12.8 are actually going to give me 2 triangles. And that's what's weird. So I'm going to show you where that second triangle comes from and how to do the math problem involving the second triangle. So in this situation, for this triangle that you see in front of you, what I'm going to do is I'm going to show you that this segment CB, which is equal to 12.5, could actually be rotated around and form a second triangle. Now you might not believe me because as I move this red line around, it just changes its side randomly. Like I could say that this is a second triangle, but this red line's not the same length. So the way that I can show the same length is I can actually first draw a circle. And the only point in drawing that circle is to show you that if I draw a line on the edge to from the center of the circle, which is C, to this edge, we call that a radius. And if I keep that on the edge of the circle the entire time, what we know about the radius lengths is that they are always the same. So that red line I just drew intersects the circle and the triangle at the same time, which means that that red line is exactly the same length as this 12.5 originally. So this is also 12.5. So I have this original triangle that I saw with A, C, and B. Let's see if I copied that. I did. So this is the original triangle, A, C, and B. And I found that B was 79.8 degrees. And then we also found that C was 26.2 degrees. But what I'm demonstrating right now is that this side length in red, I'm going to make a little note to where it intersects. Okay, this 12.5, I drew the circle to show you that this 12.5 on the right is the exact same length as this 12.5 here, because these are the two spots that the circle intersected this bottom side, C, which means that what I really have is I have this second triangle formed. And so to show that better, I'm going to do this and then erase it because I do want to see this in a moment. But I actually have this triangle up here. And so now this is my second triangle that I'm trying to find. And so with the given information that you see, 74 degrees, 12.8, 12.5, that's the same given information in black here, 74 degrees, 12.8, 12.5. And I can actually form 2 different triangles with that exact information. And so I need to solve for the 2 triangles. Now I'm going to bring this, the stuff I erased back, so we have it. I also want to show you that on this diagram that we did with the triangle, that if I try to do the same trick with a circle, it won't work. So if I start with a circle with the center of C, and I go out to this edge B, and I draw this length CB, if I rotate around the edge of the circle, this one never intersects the triangle again. And that's how I know for a fact that this length CB of 15 is only going to form 1 triangle and not form 2 triangles because it never intersects again. The other one that I showed you, if you go back and watch the video, when I dragged around that red line, it intersected the triangle in 2 spots, at B and then at a second point that we'll also refer to as B or B prime. So for the first example, the reason we went through and solved this one was to show you that sometimes with the given information, you do just have 1 triangle. And sometimes with the given information, you have 2 triangles. Now I know we're 8 minutes into the video, but what we're going to do next is show you how to find the second triangle and explain where that comes from. I'm going to draw this other side out here, CB, to show that that again is that same 12.5, and also highlight the fact that this red triangle, if I kind of draw your attention to it a little bit more, if I look at just this triangle highlighted in pink, this triangle is an isosceles triangle because both of the legs are 12.5. If it is an isosceles triangle, that means that its base angles are congruent. So if one of the base angles is 79.8 degrees, then the other base angle has to also be 79.8 degrees. And anytime there are 2 triangles that exist, both the little triangle we have at the bottom that we kind of drew out like this, okay, that was the 74 degrees. And then the 12.8 was right here, and the 12.5 was right here. It was just kind of this weird, small, obtuse triangle. that when that is formed, it's also going to create this isosceles triangle that I just highlighted in pink. The reason that is important is because it tells me how to find this other angle B. There is a second angle B, we'll call it B prime, that exists right here. Okay, the original angle B existed right here. It's the same as this base angle, 79.8 degrees. And so this new angle B is going to come from 180 minus 79.8 degrees because those two angles form a linear pair. So 180 minus 79.8 degrees is 100.2 degrees. And that is my new B right here, 100.2 degrees. And now I just have to treat this as two separate problems for the law of sines. So again, I'm going to erase so you can see that a little bit better. Okay, so I have two triangles. And now I can solve this triangle. We'll call this little c at the bottom C prime, angle B prime. This angle at the top we'll call C prime. And so we will solve the same way we would normally do law of sines, but we'll solve for this triangle. Versus the original triangle, I can use law of sines one time and find C. And we can go through and that would be the two triangles that exist. Here's a way that I can check that that would actually work. When I did that 180 minus the 79.8, if I take that 102 degrees with the original 74 degrees and I add those together, I'll get 174.2 degrees. That means that there is enough room that if I subtract 180 minus 174.2, I'll get 5.8 degrees, which is my C prime, 5.8 degrees. And that also tells me that this triangle does in fact have a second triangle because there is enough room to create a second triangle. It's the algebraic way of showing me wrapping that side around the circle. This triangle that I already showed you originally, we could not wrap it around. When we took this side length in green and we tried to wrap it around, it never intersected the circle again. It came way over there as it went around. If I didn't know that and I said, okay, well, maybe there's this second triangle. Won't let me write for a moment. So maybe there's this second triangle and there's this second B and we're trying to figure out what that is. Well, if that's the case, then these have to be base angles, 26 degrees if this were to happen. And so B prime would again equal 180 degrees minus B. So 180 degrees minus 26 degrees is 154 degrees. So if there was a second angle and a second triangle, that second angle would have to be 154 degrees. If I take 154 and 58 and add them together, it's over 180 degrees. That means that this angle, 154, cannot exist to form a second triangle because it's too big. So let's kind of summarize all that and what you actually need to do by looking at this problem from start to finish. So I have a triangle. I don't want to necessarily draw it out for you because sometimes it's hard for you to draw out the triangle. So I just want to show you what would happen if I start from the beginning and I apply the law of sines. I would start with 29 over sine 31, and that would equal 46 over sine of B. Okay, so I'm going to use my calculator and find out what that is. I would cross multiply, so I'd have 46 sine 31 divided by 29. 46 sine 31, close my parentheses, divide by 29, and I get 0.81. I take the second sine of that, and I get 54.8 degrees. So B is equal to 54.8 degrees. Put a little asterisk by this because this was the first angle I solved for. Okay, I already had angle C, but this was the first angle I solved. Now, if I continue with this process, I would find angle A. Angle A would be 180 minus the 31 from angle C minus the 54.8. So 180 minus the 31 from C minus the 54.8. I get 94.2. And then I can set up the law of sines to find little a. I already have angle C, side B, side C. I have angle B, angle A. So if I set up the law of sines for little a, I would say a over sine 94.2 is equal to little c over sine 31. And so I could find a, 29 times sine 94.2 divided by sine 31. I get 56.2. All right, so 56.2 is kind of large, but it is across from the largest angle because the largest angle is 94.2. So there is this possibility of a second triangle that could exist. Again, I could have given a triangle where the second side rotated around and made a second triangle right here. And so I want to see if that's going to happen. So to find the second triangle, the first thing I do is I go back and I look at what is the very first thing I found. The very first thing I found was angle B, which was 54.8 degrees. And so that would have corresponded to like this spot. If there is a second triangle, when I form it, it will make an isosceles triangle so that 54.8 will be in both spots. My second angle B, B prime, would be right there. And that forms a linear pair with the original B. So my new B would equal 180 minus 54.8. And I get 125.2. So if there's a second triangle, the second B would equal 125. I can check right away with this 125 to see if a second triangle actually exists. If it does, that 125 has to fit in a triangle with the original 31 degrees. Well, 131 plus 125.2 gives me 156.2, which means that there is in fact a second triangle because this number is small enough that there's room for a third angle. So 180 minus that 156.2 gives me 23.8, which means that this little angle up at the top in the second triangle is going to be the second angle A, and it's going to be 23.8 degrees. Then I can do the law of sines one more time to find side A, and I'm finished with the process. You might need to watch this video a couple times to make sure you fully understand everything that's happening.